ideally, this should be reviewed. Okay? Projectiles Lesson 1. We're going to start out reviewing what happens when you throw something straight up and down. And then what we're going to move into is, hey, let's throw something properly. Let's throw it up at an angle. And your hint is going to be components. We're going to use components. We're going to use some vector math. So, Lesson 1, free fall. If gravity is the only force acting on an object, we say the object is in free fall. We're going to ignore air resistance, Sabrina. I know technically a wadded up piece of paper falls at a different rate from a bowling ball, but in a vacuum, or if we ignore air resistance, or if the shapes are the same shape and pretty aerodynamic, everything falls at the same rate. It's a bit misleading to call it free fall because an object is in free fall even when it's on its way up. It's falling. That's a bit counterintuitive. When an object is in free fall, it'll be accelerating downwards at 9.8 meters per second squared, or to show the downwards negative. And when I'm going to start to do this unit, because we're going to have stuff, Zach, moving both up and down and left and right, I'll often call the vertical AY. I'll call the horizontal AX. I'll call VX and VY. Oh, did I introduce some of that last unit? Oh, great. Okay. Example 1 says, fill in the following key facts about projectiles. So what we're doing is we're standing on a cliff, we're leaning out over the cliff so that our arm is in midair, and we're throwing or launching an object straight up. So when it falls, it's not going to hit the cliff. It's going to go all the way down to the ground. Got the image? Okay. What can you tell me about the velocity at the very, very top? Okay, that one I know. For a split second, it comes to the top. What about when it gets even with where you launched it? When it comes even with your launch height, what can you tell me about the velocity? Okay, let's use numbers. Suppose I launch this at positive 10 meters per second. How fast is it going at the top? How fast is it going when it gets back to me? So I'm going to say when it's even with the launch, V equals negative VI. Now, if it's allowed to fall further, then it's going to speed up negative more and more and more and more and more. But I do know, you know what we said? What goes up must come. That's kind of how we remembered it. We said, you know what? When it gets back to the same height as it started from, it's going to be going the same speed. Velocity will be negative direction. What about the time? Well, T equals VF minus VI over A. I used VF equals VI plus AT, and I rewrote it to get the T by itself. Except, what's the velocity when we get back level with the launch? What did we just write? You know what? I'm going to go negative, and I'm going to scribble out the F and put an I there. That's V final. And here's really what I see. I see negative VI minus VI. That's like negative X minus X. What's negative X take away X? Not 0. Negative 2X, right? It's minus take away minus is more minus, not 0. So you know what? The time is negative 2 VI over A. I don't really memorize that. I can derive it, but for what it's worth, that's the time. Trick question. What's the displacement when you end up back where you started from? 0. What about if we keep falling, if we keep falling, if we keep falling? What's the displacement here? Positive or negative if we end up below from where we started? Okay, I'm going to say the displacement is negative D, and to show it's vertical, I'm going to call it Y. And really what I'm saying is, hey, as soon as you're dealing with a cliff, please, Alex, remember that if you're ending up below from where you started from in vector land, we better call it a negative displacement. Example 2, a projectile is thrown up from the ground, leaves the thrower's hand at 10 meters per second. A, how long does it take to reach the top of its trajectory? What's it asking me to find in part A? Okay, T equals question mark. Hey, let's review our little DFIC approach. What else do I know? What's VI? 10? What else do I know? VF? At the top, what's VF? 0. What else do I know? Oh, A is negative 9.8. So I'm looking for an equation on my formula sheet that has time, VF, VI, and A in it. VF equals VI plus AT. Get the T by itself for me, my friend. 0 minus 10 all over negative 9.8. This is almost going to work out to 1. Not quite, but close. Come on, calculator. There we go. More than one number on the top, 0 minus 10. Or you could just type in negative 10, because that's what 0 minus 10 is, divided by negative 9.8. It's almost negative 10 divided by negative 10, not quite. 1.02 seconds. B. Jacob, what does B want me to find? Now, height, though, is not one of our variables, although it says height. What's it really asking us to find in terms of our physics terms? D. You know what? I'll even call it dy for the vertical distance. Actually, a displacement for that matter. So I'll go dy equals question mark. Have we turned the page? No, so I won't bother redeficking. I got all my data listed right here, but if I turned the page, I might relist my data. Hey, I'm looking for an equation. Has to have a D in it. It would be nice if the D was by itself, and it has to have some combination of VI, VF, and A in it. It can have T. I'm okay, because I think now I'm confident enough that I also don't mind using the time that they gave me. But if I don't need to, that's also fine. There's 2 ways I can solve for D. Which 2 ways? By the way, you may want your formula sheet out. I see Jacob is reaching for it. Thank you, my friend. Josh is saying, got them all memorized. Okay. Can you give me one equation that I could use to find D and get the D by itself if necessary? Okay, so one I can go D equals VIT plus a half AT squared, and one I can go VF squared minus VI squared, Carly, what was it? All over 2A. That was the one that you said, I think, yeah? To be honest, if I had time, no pun intended, I'd probably do both. If I get the same answer for both, then I also know I did A right. If I'm a good test writer, I'd probably choose this one because that uses data that they gave me. If I was doing my homework and I was in a rush, I'd do this one because I can type this straight into my calculator showing no work and I got the D by itself. And I honestly can do this one in my sleep. Let's do this one. And then we'll quickly crunch this one on our calculator as kind of our built-in error check and go, woohoo, okay. So it's going to be D equals VF 0 squared minus 10 squared all over 2 times negative 9.8. 0 squared minus 10 squared. Really, I could have gone straight to negative 100. Divided by 2 times negative 9.8. I get 5.1 meters. And then quickly I could also say 10 times 1.02 plus a half times negative 9.8 times 1.02 squared. And I get 5.1 meters. And I smile and I say, I know I'm right. Example 3, I like this question, I like this question, I like this question. Projectile is thrown straight up at 35 meters per second off of a 70-meter high cliff. Find, okay. What do they want me to find in part A? Hello. What do they want me to find in part A? Time to top. What do we know? VI is, what else? VF is what? Only because we're going up to the top. Okay. What else? Oh, you know what? This is just the same question as we did in part A. It's going to be T equals VF minus VI over A. It's going to be 0 minus 35 all over negative 9.8. Oh, that's wrong. I missed a decimal, didn't I? Do you get 3.57142857? I'll go 3.57. 3.6 would be the 2 sig figs and technically correct. But you know what? I'll write 3.57 and then I'll write 3.6. 3.57 to 2 sig figs, Brad. 3.6 seconds. Give a whole page for this? Yeah, good. What's B want me to find? You know what? Let's do the same thing we did before. What was it? D equals VF squared minus VI squared all over 2A. By the way, a comment on this equation. I see a lot of kids, because there's so many squareds in the equation, that they want to square root their answer. Is it D squared? So do I need to square root? No, but that's a common mistake. I even see that in my physics 12s. I'll see them go, 0 squared minus 35 squared all over 2 negative 9.8. Oh, and I'll call this vertical distance dy. 0 squared minus 35 squared divided by 2 times negative 9.8. 62.5? Cool. C. What does C want me to find? Max height above the ground. How can I do that? Isn't the answer 62.5? Minus it from 70? Or add? I don't know. You know what? We probably should have dulped somewhere. There's my cliff. That's 70 meters high. And we're going like that. So if they want the total height, what do you think, Olivia? Add it to the 70 or subtract it from the 70? I think most definitely, I think the height is going to be 70 plus the 62.5, which I think I can do in my head. 132.5? Yeah. Okay. What's D want me to find? Time. Didn't we find time in part A? Or was that a different time? Oh, different time? So, okay. T equals time to fall from the top to the ground. Okay, so now we're starting at the top. What do I know? Ah, my V initial is going to be 0. What else do I know? Acceleration is negative 9.8. That's not enough. What else do I know? Height's not one of my variables. Oh, a distance? What? 132.5 is incorrect. Why would it be negative? Are we ending up above or below from where we started from? So would you like to modify your answer, Olivia, my love? Negative 132.5. Brilliant. I knew I could count on you to see the light. So I'm looking for an equation that has T, VI, A, and D in it. This one? D equals VIT plus a half AT squared. Okay. Woohoo! So really, what I have is this. D equals AT squared. And instead of the 1/2 in the front, I'll put it on the bottom like that because that looks a bit cleaner. It's AT squared over 2. What am I trying to find? How would I get the T by itself, one wonders? What would I do with the A? Divide? What would I do with the 2? Times? What would I do with the squared? So if I hear you correctly, and I think I do, you're saying T is going to be 2 times D divided by A, square rooted. It's going to be the square root of 2 times negative 132.5 divided by negative 9.8. Now, Olivia, here's the beauty of this. If you had missed that negative, you probably would have caught yourself on this line because you would have gone like this. 2 times 132 point... Oh, you would have turned the calculator on first. 2 times 132.5 divided by negative 9.8. And then you would have said square root of that. And you would have gone, huh? You would have got some kind of an error on your calculator. And hopefully what nature is saying is, I'm sorry, I can't do what... I can't go down and end up above. That's what it's really saying. So then you'd catch it, and you'd say, I need a negative right there. Do we all get 5.2? Almost even? Seconds. E. Now, by the way, I like this question, I like this question, I like this question. Not on your vectors test, but on your projectiles test. And I would have no problem, Zach, jumping straight to part E, for example, and expecting you to clue in. You need to walk through some of this, right? Speaking of Zach, I've scrolled down. What does he want me to find? Sorry? Oh, total time? Suggestions? You know what? I think it's going to be time up plus time. Isn't it just going to be time up plus time down? Because time's a scalar. Time up was 3.6 seconds. Time down, 5.2 seconds. I think I can do that in my head too. 8.8? What else could I ask you? I didn't hear. I could ask you to find V final at impact, the impact velocity. It would be negative. It would be bigger than 35 because it's kept speeding up after it falls past where we launched it from. I can tell you that much. It would be find V final and see what kind of data you got. Next page. Sure, we'll do this. I think I can get all this done. Example 4. A person bends their knees 20 centimeters, pushes on the ground, and flies 50 centimeters into the air. We actually did this as a little lab activity. We had one of you jump. We measured your vertical height, and we measured how far you bent. It was the same day we did the reaction time activity. A says, find the speed when they leave the ground. B says, find their acceleration during the push. C says, find how long they are in the air for, their hang time. Okay. Let's see. I think we have to divide this into two sections. Then I got room down here? Yeah, I do. Good, 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 good. While you're on the ground and while you're in the air. While you're on the ground, this is before you start to straighten your legs to once you've straightened your legs out. While you're in the air, this is while you're in the air. Anything we know that I can put under either of these columns? Oh. 0.2, 0.5, got to go to meters, right? What else? So what we're talking about then is this, straightening the knees out as fast as you can, flying into the air with an impressive vertical, and then landing. So what else do we know? Acceleration, which one where? Or both? Oh, what's my acceleration while I'm in the air? Because I'm in free fall? Good. What else? VI? For which one, ground or air? What's VI, ground? On the ground, I'm starting at rest. Okay. What else do I know? VF for the air? What's VF in the air? At the top, I'm going 0 for a split second? Okay. How many things do I have in the air section there? 3. You know what? If I got 3, I can find 4. I'm going to pause with the ground. I'm going to go see what I can see here. Certainly, I think I can find VI. Is there an equation that has distance A, VF, and VI in it? VF squared equals VI squared plus 2AD. Okay. How would I get the VI by itself? Minus 2AD, and then? Okay, so I think VI is going to be VF squared minus 2AD, and then square root, which is going to be 0 squared minus 2 negative 9.8.5. 0 squared, I guess I could have just ignored that, minus 2 times negative 9.8 times 0.5. I think the 2 and the 0.5 will cancel. Square root of 9.8. 3.13. What was that? Zach, what was that? That's your V final when you leave the ground is 3.13 meters per second. And you know what? That's what they wanted me to find in part A. So I'll put a little part, there's my answer to part A. Hey, Zach, how many things do I have now on the ground side? Then I can find the fourth. What do they want me to find in part B? All right. A equals question mark. I'm looking for an equation that has D, VI, VF, and A in it. VF squared equals VI squared plus 2AD. Wouldst thou be so kind as to get the A by itself, please? Watch and learn, Zach. Watch and learn. 3.13 squared minus 0 squared all over 2 times 0.2. I should get a positive answer because while I'm straightening my legs, I am accelerating upwards. Ideally, I hope. This number squared minus 0. I guess 0 squared doesn't make a difference. I probably didn't need to type that, but some of you get nervous if I don't show everything, so okay. All divided by 2 times 0.2. $24.5. Units, meters per second squared. Hey, that's my answer to part B. This is kind of jumbled up for the work, but I'll try and make it clear, right? Taylor, what's C want me to find?
How long are you in the air
The hang time. I think did you say in the air? I'm going to be on the right-hand side, and they're asking me to find T. Okay. I'm like, oh, I got lots of room. Good, 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 good. T equals question mark. What do I know? Well, A. What else do I know? VI? 3.13. What else do I know? What's VF? Now, if I do that, that won't give me the hang time. What that will give me is time to top. Hang time is time to top and back down. Is there a way? I'm okay with that because I think I could find that and just double it. But is there a way that I can get there in one fell swoop? I do know VF. Ah. Negative 3.13. I can use what goes up must come down, and I can find T in one step. I would have no problem if you found time to top and doubled it. I would have a problem if you found time to top and said, that's the hang time. No, he comes back down to, or she comes back down to. T equals VF minus VI over A. Third time today I've seen that puppy. Negative 3.13 minus 3.13, negative 9.8. Now, I am using a piece of data that I calculated to find another answer. You know what? I'm confident now, Alex. I can get away with that, I think. And I get a hang time of 0.64 seconds. Basketball boys, there was a playground legend in New York named Herman Helicopter Knowings, and the story goes that he got called for 3 in the key while hovering above the key. How high would he have to jump for this to be a true story? Because that's the legend. I don't know. Well, I know that the time is 3 seconds, because that's what 3 in the key is. I know A is negative 9.8, because he's in the air. I know at the top, oh, wait a minute. If I let the top be 0, what do I really want the time to be? No. 1.5, right? What goes up must come down. So if I let V final be 0, I'll let this be 1.5 seconds. That's how long it took him to get to the top, and he would have taken the same amount of time to get back down. I want that. Do I have an equation that has D, VF, A, and T in it? You know what? This is going to be a 2-step. What can I find right now? I think I can find VI. Ignore the D. Is there an equation that has time A, VF, and VI in it? Yeah. Get the VI by itself. Let's see, VF equals VI plus AT. Oh, I guess it's going to be VF minus AT. Is that okay, Oliver? Yeah? Which is going to be 0 minus negative 9.8 times 1.5. So for this to be true, Herman would have had to leave the ground at 14.7 meters per second. Is that possible? Well, I don't know. Let's see. So now I've got a VI. Now, Alex, I can go D equals VIT plus a half AT squared. If it was possible to hover in the air for a total of 3 seconds, on the way up 1.5, on the way down 1.5, how high would this person have jumped? 14.7 times 1.5 plus 0.5, negative 9.8, 1.5, don't forget the squared. Is this feasible? I know people with very good verticals, with very good vertical jumps, can jump around 1.5 meters or so. Andrew Wiggins, I think, did about a 43-inch vertical the other day. 30 inches is 1 yard, so a meter is a bit more than 30 inches. So 42 inches would be about 1.5 meters, give or take. What do you get? Sorry? Well, why is that stopping you? It's just squared. What do you get? Sorry? 11 point? Oh. Basically, if this was true, he would be able to leap small buildings in a single bound, right? 1 story is around 3 meters. This is around 3 stories. So he would be able to leap to the top of a 3-story building. Can a human being do that? Okay, so you know what? Without ever having seen it, it's an urban legend. No way. No way. Okay. Can't be possible. Can't be possible. What was that? Huh. Every week, whenever it's on. Went and saw him last weekend live. It was great. You know what? Example 5 is cool but nasty. I'm going to pass on it because I want to try and give you guys the weekend with no homework. I want to give you the weekend so you can do the review and work on your vectors. So next week, is Friday a day 1, 3, or is probably Friday next week is a day 2, 4, I suspect. So I guess this is going to be due not this Monday, but the following Monday. You'll have the vectors test, and you can work on this. What's your homework? Number 1. 2 is good. 3 is good. 4 is algebraic. I probably won't ask you algebraic this year, but those of you that are thinking about Physics 12, more and more what we'll start to say is rather than solve a specific question with numbers, we'll say, hey, let's get the algebraic equivalent. We can solve any situation like that. So if you start getting comfortable with the algebra, you can try 4, but don't freak out if you're like, 5 is good. 6 is good. Yep. 8 is good. Skip 9. Nice try. Yeah, 10 is good. All of you in number 10, underline the word downwards. What's VI? Don't say 5. Negative 5. And then everything else should be good and okay. Your initial velocity will be negative 5. What's your displacement? Negative 30. A is negative 9.8. And you should be able to find T. use, anybody know what QF stands for? I think for number 10, you're probably going to need to use the quadratic formula. If not, I'll talk about this when I see you guys again. And 12.